All right, 6.2 is unit rates. So we're going to be we're still going to be setting up ratios, but now instead of just reducing them down to the most reducible fraction, we're going to be converting them into decimals to answer questions. I do want to make sure to point out that if it has to do with money, you need to make sure that your answer is a money answer. So on these, remember I said on ratios, I didn't care if you labeled them, right? And maybe that was a bad habit to let you get into in 6.1, but you didn't really have to in 6.1 as far as I was concerned. But in this, you do have to label your answer. Okay, so these kind of almost go into the realm of story problems. And you guys know with story problems, you always need to have a label for your answer. And it's the same way with this. And if it has to do with money, somewhere in your answer needs to be money as well. Okay, and we'll kind of do a few examples and I'll show you what I mean. All right, so if we look at example number 1, we've got $4.60 for 5 cans of soup. So we want to know the unit rate. Well, what that means is for every 1 can of soup, we want to know how much it costs. Well, you still set up a ratio and you put $4.60 per can or per 5 cans. Okay. Now you can do this, and I want to test out something because I want to see if it would help to do it this way every single time. Yeah, it still turns out being the same thing. All right, so what I want to know here is I want to know how much it costs per unit. Okay, this is what unit rate means. So that means for 1 can. And if you'll notice on the top, I have money. And on the bottom, I have cans, right? So it's $4.60 per can. So it's money on top, cans on bottom. And what I want to know here is how much is it going to cost for 1 can? Well, if I divide $4.60 divided by 5, that's going to tell me, it's going to give me 0.92. And what that means is that per 1 can, it's 92 cents, and then you want to put per can. And I don't care if you put of soup, I'm fine with just per can. Okay. So you still set up the ratio. Now there's I don't know, there's longer work that goes into this. And when we get down here to these story problems, you are going to have to do the longer work. So I'm going to take the space under number 2 because we're not going to do number 2 and just show you kind of the work behind why this works. So again, my initial fraction I set up was money over cans, right? That was my initial fraction. In the given information, I had $4.60 for 5 cans, and I wanted that to equal some amount of money. I don't know the rate, the unit per can for 1 can. Okay. Do you guys know how to, I don't know if you've done this before, so I'm asking, have you solved equations, 2 fractions equaling each other? Is that something you guys have done yet? Okay. Well, when you've got 2 fractions that equal each other, it's kind of I don't know, it's a silly reminder, but it's the butterfly trick. So if you think of what a butterfly, okay, we're going to go this way and we're going to go this way. And the reason I'm showing you the long way is because when we get down at the bottom half of the page, you are going to have to use this longer way. So you cross multiply. So you multiply 5 times x to get 5x equals, and then you multiply 1 times $1 or $4.60, which still stays $4.60. Now, when you solve for x, what are we going to do? We're going to divide by 5 and we're going to divide by 5. And when we do that, we get x equals 92, right? Now, notice I got the same answer in both spots. I got 92 cents. Doing it this way, it's the same thing. You're just not showing all of the work in the middle. You're still dividing. Notice I still get this fraction right here. And notice that fraction right there looks a lot like that fraction right there. And I still put in my calculator $4.60 divided by 5, and I get 92. And because we're talking 92 cents per can, Okay, you still are going to label it the same way. So with all of these, you're going to have an initial fraction like I did here. Okay, this is your initial fraction. Here was my initial fraction, right? Money over cans. When it's just figuring out the unit rate and there's nothing missing, and when we get down to the bottom, there's going to be some missing information. So you have to set it up like the butterfly. When there's no missing information and you just have 460 for 5 cans and you want to know the unit rate, which means you want to know what it is for 1 can, you just simply divide. Okay. That's the long story behind why it works, but the short way works for most of these. And I'll show you in the short way when you have to use the longer way. Let me erase all these circles so I can get those out of my way. There we go. All right. So for number 3, okay, I'm just going to do this kind of the shortcut way for now because we can. So we want to know if we have 652 miles, 652 miles in 9 days, we want to know how many miles you can do in 1 day. So you divide, and this is why I wanted you guys to have calculators because I want you guys to do this. So Gage, tell me the answer. Okay, now wait a minute real quick. What's it say up here? It says round to the nearest tenth or cent if it's money, right? Cent if it's money, tenth if it's not money. So go ahead and round that for me. 72 point what? So how would we round that? To the tenth. No, just rounding is just. So if you guys remember how to round to the 10th, hopefully I'm going to show you. So he said it was 44444. Here's the 10th spot. To round to the 10th spot, you look at the 100th spot. If it's below 5, you leave it as a 4. If it's above 5 or above, you round it up to a 5. Okay. Hopefully you guys remember how to round. So 72.4, and then we have to label this. Okay. Every single one of these is going to have a label. It's 72.4 what? Anybody? Miles per day. Every one of these, because they are unit rates. And if you want to put this up here, okay, your answer is going to have a per in it. Okay, your answer is going to have a per in it because it's a unit rate. It's something, something per something, always. Okay, it's something per something for your answer in all of these. Okay. All right, so let's look at number 5. 176 new employees in 22 years. So we want to know how many employees in 1 year, because remember, unit rate always gets the denominator to be a 1, because we want to know something happened in 22 years. What would be the equivalent in 1 year? Okay, unit rate is always in your denominator is always a 1. Cam. 8 employees. What's the word it's got to have? Per year. Notice my per, it's employees, right? And then the word per, and then years. So your answer should match your question. Employees in 22 years, employees per year should be your answer. Okay, how about 55 pages in 25 minutes. So we want to know in 1 minute. Noah, what's the answer? And remember, we're rounding to the 10th because this is not money. 2.2 what? Nope. Look at your problem. Pages what? Pages per. You don't have to put 1. It's assumed it's 1. Pages per minute. Pages per minute. I do want to do $1 one just to make sure that we know how to round it and how to label it. So it's $3,015 from 36 people. We want to know how much one person gives. So we divide it, and Briley Dyer, what's the answer? And we're rounding, remember it's money, so we're rounding to the cents. 83, wait a minute, 83 point what? Well, we need it to be money. So we need, remember change, you always have 2 decimals. 75. And remember, this is dollars. So it's $83.75. What? Per person. Good. Every single answer needs to have per in it. Okay. $83.75 per person, 2.2 pages per minute, 8 employees per year. Okay, 72.4 miles per day. And notice again, like I said, looking at number 3, right? You've got miles, and so you've got miles per day. So you've got day. Okay, your title and your answer should always, or your problem and your answer should always match. All right. So now let's look at number 9. It's a story problem. And this is why I printed out your notes, because I did not want you to have to try to write down all these story problems. We've got Happy Times Summer Camp has 356 campers and 38 counselors. So that's 365 campers to 38 counselors. Playday Summer Camp has 219 campers and 28 counselors. Which camp has the lowest rate of campers to counselors? Well, to answer that, we have to figure out each one's rate. So first, we're going to do Happy Time, right? So we're going to do Happy Time in purple. So Happy Time has 356 over 38, 356 campers to 38 counselors. And we want to know what it is for one counselor. So we divide, and Jackson, what do we get? And round to the 10th when it's not money. No, not to the whole number, round to the 10th. So 9 point, did I punch it in wrong? 356 divided by 38 is 9.36. So 9.4. So we got 9.36. We want to round to the 10th. So we use the 6 to tell us to round up or down. Does that make sense? So the 6 is higher than 5. So that tells us that it equals, almost equals 9.4. All right. So at Happy Times Camp, there is 9.4 campers for every one counselor. Okay. So now we want to figure out Playday, right? So Playday has 219 and 28 counselors. So 219 over 28 and Josiah Swick, what is the counselors or campers to counselor ratio here? 7.8. Okay, and that's 7.8 campers, right, per counselor. Okay, so the question was, you always have to look at the question of each problem. Which camp has the lowest rate of campers to counselors? You can't, we're not actually asking how many campers. We're tallying a ratio so that we can answer a question. If the question was, how many campers were there per counselor, you would round to either, well, you'd have to round to 7 because you can't have 7.8 and you don't quite have 8, right? So if the question was at Playday campsite, what's the most amount of campers per counselor? Your answer would be 7, right? But we're not asking that right now. We want to know which camp has the lowest rate of campers to counselors. Well, I said it'd be a little bloody. Yeah, we're not going to do that. Yes. Which camp has the lowest rate of campers to counselors ratio? Yeah, the blue one, Playday. So your answer here, all of this work I did, don't circle any of that. You have to show it because you have to do that. But your actual answer is Playday because that's the answer to the question. The question was, which, I'll highlight it here. Let's do red. So my question was, which camp has the lowest rate of campers to counselors? So your actual answer that you're going to answer is Play Day. Okay, so that's what you're going to circle as your actual answer. You just have to show all of the other work to be able to answer it. Do you have your pass? Okay, it's first hour, so, but that's okay, I'll call her. So again, you have to, when you start getting into story problems, you have to do the work, but then you have to go back and answer the actual question. So always pay attention to what it's asking, all right? A roller coaster can accommodate 346 riders in 20 minutes. Here's our question. How many riders could ride in 90 minutes? This is where I was talking about we're missing some information, okay? If you set up a ratio, and I want you to do this on every single one of these that's missing something, okay? If you set up a ratio of riders, and I want you to actually write out this right here, riders to minutes, you're giving yourself a framework that you're going to use throughout the whole problem. Riders are always going to be on top, minutes are going to always be on bottom. You look at the roller coaster, the first group of information they give you is right here. Let me circle it in yellow. That's the first that's the first ratio they give you, right? 346 riders in 20 minutes. So my riders goes on top, so 346 in 20 minutes. Now the question is, how many riders could ride in 90 minutes? Well, I have another partial fraction. So I'm going to set them equal to each other. Okay. I'm going to give myself another fraction. I'm given 90 minutes. Is that going to go on top or bottom? Bottom, because my minutes go on bottom. Now my question is, how many riders? That's my unknown. I don't know that. So I have to put a variable in that spot. You can use X, you can use R for riders. I usually just use X generically all the time, but I don't care what you use, just don't use an S. So I don't know the number of riders. So I basically, out of two fractions, I only have 3 bits of information and I have 1 piece missing. This is where that butterfly effect comes in. You multiply, cross multiply to get 20x equals, cross multiply the other way, 346 times 90 is 346 times 90 is a big number, but that's okay. 31140. Now what do we have to do to solve for x? We need to divide by 20, divide by 20, and we get x equals 1557. Now this is a story problem. We have to label this. And in our possible labels, we have riders and minutes. What were we solving for?
How many riders could ride in 90 minutes?
Yeah, right. You can just put riders because the answer to the question is how many riders. So the question is how many riders? Your answer is 1,557 riders. If the question is how many riders, your answer needs to be how many riders. So 1557 riders. Needs an S. There we go. Okay. These are going to be a lot of work to get to an answer. Circle your answer, but you still have to show all of your work. Okay. All right. The bakers at Joey's Bagel can make 340 bagels in 4 hours. I'm going to set up my initial fraction of bagels over hours. And I don't care if you abbreviate as long as your abbreviations make sense. Okay. So my fraction is always going to be bagels on top, hours on bottom. I'm given 340 bagels in 4 hours. And then look at your question, right? Your question is how many bagels could be baked in 10 hours? That's my question. So I'm going to set up the other half of my equals. How many bagels? So where's my variable going to go? Zach, what do you think? Where's my variable going to go? Top or bottom? Yeah. How many bagels? Don't know the bagels. Can be cooked in. Jaden, what am I going to put in the bottom? 10. Good. Now I'm going to do the butterfly. Okay. Anytime you have two fractions equaling each other, you cross multiply. So I get 4x equals, and then I do the other way. And that's 3400. And then I have to divide by 4 and divide by 4. Who said it? X equals what? X equals 850. And how am I going to label that? Bagels. Good. Okay. We'll do a couple more. All right. The price of various sizes of Health Crunch cereal are given in the table. Which size has the best cost per ounce? That tells you you're figuring unit rate. How do you figure unit rate? You take the cost, right? We did this up above. You take the cost divided by the ounces. So this is, let's do this. Yeah, this will work. We'll do the first one in black. So this one I'm going to do in black. Okay. And there's no shortcut. You just have to tally all three and then answer the question. And again, right, what's your question here? Your question is, which size has the best cost per ounce? Okay, so we have to tally them all first. We don't know until we tally them all. So Noah, what's the answer to the first one? And remember, this is money, so we're reducing it to cents. .43, right? And it's 0.43 per ounce, right? All right, now we have to do the same thing with the next one. Lakin, what's the answer to the next one? How am I going to set it up? I'm doing this blue one now. What do I put on top? What do I put on top? I didn't hear you. Okay, 485. What do I put on bottom? Okay, now tell me the answer. And then just to get somebody going, somebody I haven't talked to yet, Josiah Falk, what's the answer to the next one down? We'll get kind of going on two of them at once. You're going to do the purple one. No, hang on. 4.85. 4.85 divided by 15. Read off what you get.
0.3233.
Okay, so 0.32, right? And that's dollars per ounce, right? And then the next one is a purple one. Josiah, how am I going to set this one up? This one right here. What do I put on top? Nope. Look at the other ones. What I put on top? 589 on top. What goes on bottom? 19.1. Okay, punch that in your calculator and tell me what you get. I think it's 0.31. Is that right?
Yeah.
Okay. And that is, remember, dollars per ounce. So which one of these, who haven't I heard from today? I've heard from you. Jada, which one of these, looking at your question, which size has the best cost per ounce? What's your answer? 19.1 ounce. That's the package that has the best. That's what you're going to circle as your answer, but all that other work has to be shown in order to get the answer. All right, I'm going to skip the next two. I just want to do this last one because it's another one where there's a missing bit of information, and I want to do one more example of that. All right, it took Michaela 4 hours to sew 9 scarves. So we're dealing with hours and scarves. So if I set up my initial one, I want to know how many scarves she can do in 1 hour, right? So I'm going to put 9 scarves Whoops, nope. First, what do I always have to set up first? Don't want to do any numbers first. What do I want to write first? Yeah, either H over S or S over H, okay? Once you start with one, that's why I always want you to write it first. Once you start with one on top and one on bottom, you got to stick with it all the way through the problem. So you said hours, you said H over S, right? Hours over scarves. So that's going to be our framework for the whole problem. So if that's my framework, Jayla, what am I going to set up as my first fraction? Here's my first bit of information I'm given, right? She does 9 hours to sew 9 or 4 hours to sew 9 scarves. So what's my first fraction going to be based on my setup fraction? 4 over 9. Good. Equals. Now what's my next bit of information I'm given? Or should I say, what's my question? How many scarves could she make in 24 hours? Yes, ma'am. Rayleigh, what's my next fraction going to look like based on this information? Says how many scarves should she make in 24 hours? So what information am I given? Okay, so is that going to go in the top or the bottom? 24. Whoa, that was funky looking. Wasn't on a pin. There we go. 24 over what? I just don't like to use S because it makes me twinge because it looks like 5. So I would use an X there. But if it was something like a P or a T or something that makes sense, you could stick a T there and that's fine. All right, Gage. No, and I'm going to show you that real quick. Okay, so we're going to cross multiply. We're going to do our little butterfly, right? We're going to go 9 times 24, which is Logan. What's 9 times 24? 216. And then we're going to do our other side of our butterfly. And we're going to do 4 times X, which is simply 4X. And then we're going to divide by 4 and divide by 4. And Zoe, what do we get? 216 divided by 4. $54 what? Scarves, right? So our answer is 54 scarves. That's what we're going to circle as our answer. Now I want to answer Gage's question because that was a very good question. Okay, let's say I decided to do S over H, right? I just went with the other way on my fraction. Let me show you why you're going to come out the same. 4 hours to sew 9 scarves. 9 scarves, 4 hours, right? My scarves are on top, my hours are on bottom, equals how many scarves, so my unknown is on top, can she make in 24 hours? Hours is on bottom. When I do the butterfly, whoa, when I do the butterfly, I get 4X. When I do the other butterfly, I get 9 times 24, which is 216. When I divide by 4 and divide by 4, I still get X equals 54 scarves. So notice because you're doing the butterfly effect and you're cross multiplying, when I cross multiplied 9 times 24 or 9 times 24, it didn't matter whether or not they were left or right. Does that make sense? So you cannot mess up these as long as you keep your basic fraction that you set up at the beginning. Where you get off, where you mess up is if you start out with hours on top and scarves on the bottom, and then on the other side of the equation, you put the scarves on the top and the hours on the bottom and you change it up. That's where there's a problem. And that's why I always want you to set this up. Now, it doesn't matter when you have a missing bit of information and you're solving for X. All right, I want to say that. It does matter up here. If it gives you $4.60 for 5 cans and you want to find the unit, it matters that 460 is on top. Because if I were to punch in my calculator, 5 divided by 460, I get 1.08. That's not the right answer. So when you're setting up ratios to find unit rate, it does matter what goes on top, right, Jacob? You good? Okay. When you're setting up the butterflies problems where you've got a missing part of your fraction, it doesn't matter as long as you always keep writers and minutes on, as long as you keep your fraction straight all the way through the problem, it doesn't matter which one's on top. So if you have missing information and you're setting up two fractions equaling each other, that's when you're going to set up the basic fraction first with like b over h. If you're doing them like they are at the top where you're just finding a unit rate, then it does matter which one's on top. All right. Okay. For those of you at home, make sure you've taken notes in your binder and email me if you have any questions.